I just said all this in class. You guys know how to do all that. When I realized I wasn't about to record it, or I wasn't recording, I said this. Would we ever write this like that? No. What would we write it? What would that trinomial look like in a real math class, not as a teaching tool? This would be x squared minus 16, yes? But these would still be the factors, wouldn't they? Is everybody cool with that? So all of you should be able to discern or divine or guess what the shortcut to this kind of factoring is based on the name of this kind of factoring. I'm going to call this guy A and I'm going to call this guy B. Is everybody okay with that? And as Antonio says, you can just take the square root of the A term plus the square root of the B term and then do it again, but with the minus. Does everybody see that? Now, normally I would take way longer to teach this, right? We'd go through it forever, and we'd get out some algebra tiles, and I'd show you why it works, but we just don't have time, okay? Is everybody okay with that? This is why it works. This is the shortcut that we just did here. Everybody cool? I stress this word. That's why I'm also highlighting it yellow so it shows up green if I had a better projector. It is a difference of squares. What math is difference? No. Subtraction. So to do this plan works if it is a squared. Anything squared minus any other thing squared. Anything squared. Okay? So, would x squared minus y squared work? Yes or no? Yes, because it's a square minus a square, right? Squared, squared. Cool? Would, I'm going to put a line here because I'm going to do a few examples. Would x squared minus 9 work? Yes, why? 9 has a square root. It's 3, right? So that works. That works. Does this work? 4x squared minus 9. Why? Because 4 has a square root, right? It's 2. Everybody still cool? So that one works. Yeah? Okay. 4x squared minus 9x squared. Does that one work? Yes. Everybody still good? 5x squared minus 12y squared. Does that one work? No. Why? 5 doesn't have a square root. 12 doesn't have a square root. So that one's out. What about this one? X to the 4th minus 9. Why, Mark?
Because x4 is square root of x squared.
x4, x to the 4th becomes x squared, doesn't it? X squared times x squared is x to the 4th. So that one works. Are we cool? Okay. Now I'm going to be a real meanie. 3x squared minus 27y squared. Does that one work? Are you allowed to forget all the other stuff you have learned in math? Are you? No. So what would you do with that when you see a 3 and a 27? Divide by 3 to get 3x squared minus 9y squared. Now does it work? Yes. And finally, the last warning I want to give you is, does this work? X plus 3 squared minus 9. Why? You could make it another variable, right? Right? Everybody cool? All right, so let's do this a bit. Does this one work? Yes or no? Why? What is the square root of the first one? 4. 4? Square root of x to the 16th? 8, right? Because x to the 8 times x to the 8 will get me x to the 16. Is everybody okay with that? Does 1 have a square root? What is it? 1 plus 1 minus 1. Am I done? No, I'm not done because this is a square, isn't it? So I have x to the 8th plus 1, and this becomes x to the 4 plus 1, x to the 4 minus 1. Am I done? Why not, Mark?
Because you can still keep going with that.
Why?
Because you can do that same thing again. So that x to the 4th times x squared.
Plus 1, x squared minus 1. Am I done?
No.
Why?
You can keep going again.
Now am I done? Yes. Because these guys are plus, 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 and this guy doesn't have a square root. Plus. Everybody good? I put that one first because that's the one that makes you have to see the pattern the most times. Okay, normally I don't rely on patterns. I remind you that you can rely on patterns, but normally I don't teach by pattern. But because we're short on time, I'm going to. So look at number 2. Does number 2 work? Does number 2 work? Okay. So if number 2 is going to work, I must be going square root there, right? Well, what's the square root of x squared? X. What's the square root of y squared? Y. So even though that looks weird, you know how to do it. What's the square root of 25? 15. And then I just write it again. Minus 15. Is everybody okay with that? Should I check it? Of course I should. What's x times x? X squared. Y times y. Y squared. 15 times 15, 225. I'm brilliant. Yes? Okay. What's the next one? What's 3? Z to the what? 4 plus 12. And then I just write it again. Z4 minus 12. Now, you guys all know from your exponent laws and our radical unit that when you are taking the square root of exponents, you just divide by 2, right? You guys all should be remembering that because we've done that to death. Now, am I done? I am done. Even though this looks like I shouldn't be done. What makes me not done here? Or what makes it so I am done here? No square root of 12. Everybody cool? Yeah? Okay. 4 is tricky. Is it a difference of squares? Are both the numbers perfect squares? Yes. Are both the letters perfect squares? Yes. How do you know a variable is a perfect square? It has an even numbered what? Exponent. So is this okay? So if I square root that, what am I going to get? 2x cubed. Plus, then I square root that. What do I get? 5y. And then I just write it again. Okay? Now you will notice that's probably the end of it for you guys, right? Because usually by now, I'm able to say, okay, you now know all the tricks. So even if it looks different, you should be okay to do it. So I'm going to write a couple here at what I think is a level you guys are cool with. Okay? That's why there's so much blank space on your paper. There should be at least a third of a page. So I'm going to write a couple that you should be cool with. X plus 3 squared minus 25. That's your first one that you should be cool with. You have a trick to do that. What is the trick? Pardon? Square root both. So what is the square root of x plus 3 squared? X plus 3. Plus, what's the square root of 25? 5. And then we just write it again. X plus 3 minus 5. Now what do? What's 3 plus 5? 8. And what's 3 minus 5? -2. Is everybody okay with that one? Please notice that we have to remember our grade 9 rules to do it, right? Could I do the substitute-y thing here that I did on the board? Could I rewrite this as a squared minus 25? Which would be a plus 5, a minus 5, right? But I want a to be that. Is that cool for everyone? Antonio? Well, this had to be the square root of x plus 3, right? And this had to be the square root of 25, right? Well, 3 plus 5 is 8. Because you have like terms right there, Antonio. You have a 3 and a 5. Cool? Don't worry, you're not the only one. Is everyone okay with that? Okay, that's the first one you should be okay with, based on what you already know, right? The next way I will try to trick you is this. The next way I will try to trick you would be this. Something like, no, wait, let's add. Let's make that 3. Let's make that y cubed. That would be the next way I would try to trick you. What would you do with that? What don't you like about it? You see some variables with exponents, subtracting some variables with exponents. But you don't like those first two numbers, so what would you do? Greatest common factor, what is it? 3x cubed y, right? So 3x cubed y. What's 12 divided by 3? 4. X to the 5th divided by x to the 3rd. X squared. 27 divided by 3? 9. Y to the 3rd divided by y? Y squared. Now can you do it? You're going to get 3x cubed y, 2x minus 3y, 2x plus 3y. Is everyone cool with the second way I would try and trick you? Everyone is good? Yeah? Okay. Now the third way I would try and trick you, and this is the hardest one of these that I will give you, would be this. X plus 3 squared minus x plus x minus 2 squared. Blech! Is it squared minus squared? Yes. Does this have a square root? Sure it does. What is it? We just did it right here in number 5. What's the square root of that? X plus 3 plus, what's the square root of that? X minus 2. Agreed? And then I just write that again. X plus 3 minus x minus 2. And then what do I do in both those brackets? X plus x. What is that? 2x. 3 plus negative 2. 1. Plus 1. X minus x. Nothing. 3 minus minus 2. 5. And then I would be done. That's the hardest kind of difference of square question I can give you. Except mixing all three of these together, right? Everybody good? That's the last kind of factoring. I leave it for the end because it's a little bit different, but it's based on factoring you already know. Cool? Okay. So, I left you with page 177, number 8, 12, and something else, 14. I left you with page 114, 114 from your purple book. And I left you with page 120 from your purple book. But now you can do all of 120. Including 14, 15, 16. Okay? Now, I already know I've given you 114 and 120. What are the other blank pages in your book right now? By blank, I mean I have not assigned them to you. Not blank because you didn't do it. 116 has not been assigned. 117 has not been assigned, and 118 has not been assigned. And 121 has not been assigned. All right, now, before I let you work, I need to have a small discussion with you guys. I just want to